All right, so we left off wanting to at the point where we wanted to understand what what architecture is essentially, and then what the A in ARMv8-A mean, right? So architecture is just a document that describes how the CPU should operate, what all, how it can, well, it doesn't talk about exactly how, it only talks about what all the CPU should do. And if a company is following that specification and creating an actual chip out of it, then that's like called the implementation of the architecture, right? So maybe even before we go to what A class is, let's talk about two important keywords. One is called the architecture, and the other one is called the micro architecture, right? So you'll kind of hear these keywords a lot when you're kind of, working, let's say, with the hardware, with the actual chip, or, in the semiconductor circles, you'll kind of hear these two keywords a lot. And there's like a subtle difference between both of them, right? So architecture here, let me write it as arc, and then let's write mu arch for microarchitecture. So this is the microarchitecture, and this is just the architecture. So the architecture is a document, right? It's, so to speak, specification, right? And a microarchitecture is an actual implementation, right? And we'll discuss the details in a while, but this is an implementation, right? Now, for example, let's say you had a document that described different parts of a bicycle, right? And it talked about, hey, bicycle needs to have like two rotating something circular, have it has to move forward. There has to be like a steering, a place for the driver to sit, or the rider to sit, and so on and so forth. So you're just essentially describing like what this entity called bicycle should achieve, right? So that is an architecture, but an actual implementation by some company of that, bicycle would be, okay, this is like the seat, and then this is like maybe somewhere, handle something. So the actual implementation is then called the microarchitecture. And as you can imagine, there are n number of ways of implementing the architecture. Some bicycles might just have like, no gears, a chain and sprocket kind of an arrangement with straight handlebars. Some might actually have, gears on them, and also like a pillion seat for someone else to sit on, sit behind the main rider. And maybe, the handlebars are not straight, they are like, structured differently. Similarly, the brakes can be implemented differently. So the idea is, given one architecture specification document, you can implement like the same architecture in different ways. And the as in case of bicycle, the different implementations can have different degree of performance. In one you can go uphill easily. Maybe in another one, it's a I don't know, you can burn fat more easily, something like that. So the idea then is, the architecture can be one, micro architectures are like the implementations, and then they vary. They can vary but achieve the same effect, so to speak. All right, so that's with respect to what architecture is, what microarchitecture is. And now let's maybe talk about what this A here is. So ARM as a company makes, well, kind of gives out three types of architecture majorly for CPUs. One is called the M class architecture, the other is called R class, and then the final one is A class. And these are typically targeted to like the applications in which the CPUs would be used. So for example, if we are talking about very simple applications like, remote control, ovens, just on and off, monitor an input, take some action, wait for some time, so on and so forth. Very simple, you know, one application kind of use cases. We're talking about M, which stands for the microcontroller class of CPUs, right? And we kind of also have like a separate 101 series for the M class CPUs because they're extremely popular. So that's for like M is for the microcontroller class. The R is for the real time use cases, right? Real time class, and real time might be, let's say, the engine firing system, right? um, the engine needs to fire at a particular rate, and the hardware or the processor that's monitoring all of that firing, that cannot miss a deadline. It has to be predictable. It has to be deterministic. So for deterministic systems, the R class of CPUs is what we use, right? And then in general, when we want to have general purpose computing, like for, let's say, cloud, laptop, tablets, mobile phones, the heavyweight not uplifting, but heavyweight lifting of or executing non-catastrophic applications like Linux, Chrome browser, those kind of things, that is done on top of the A class CPUs, and A class stands for the application class, right? So your operating systems run on the A class CPUs. Now, what are the different electronics that uses the A class CPUs? Well, if you are aware of the Apple MacBooks line, which is based on the Apple Silicon, so the Apple Silicon M1, M2, M3, and M4 SoCs are based on the A-class CPU. That's the heavyweight CPU in that. Similarly, majority of the phones that are out there, in fact, I would say like 99% of the smartphones that are out there are based on the A-class, or are based on the A-class CPUs. Right. The Android phones are based on this, the Apple phones are based on this for the most part. And then the infotainment of the automobiles, that like the cars that are coming up these days, is based on the A-class CPU as well. So then learning about the A-class CPU underlying functionality, how it works, will just enable you to go and, seamlessly work in all of these different verticals, so to speak: laptop, tablets, mobile phones, infotainment units, so on and so forth, seamlessly. Also, if you wanted to learn more about, let's say, the Linux kernel, understanding one of the CPUs becomes important, and A-class can serve like a pretty good candidate in that position. So, long story short, A class is very widely used. It's all around us, and we would want to take a look at how to go about learning the CPU and what are like the bare essentials you need to know to be able to kind of contribute to a team that's working on the A class CPUs.